This lesson is applications of integration. Remember, this is the derivative of what we're seeing over here, because this is the antiderivative of what we're seeing over there. So a derivative is a rate of change, and this is showing us the total change. This is the rate of change in volume. That's going to equal the change in the volume. When we integrate a rate, we get a change. When we derive a change, we get a rate. So if we have a rate of change in population, we can get a change in population if we integrate that rate of change. If we have a rate of change in position, we can get displacement. A particle moves along a straight line, so its velocity at time t is given by the function. Find the displacement during the period from 1 to 4 inclusive, and find the total distance traveled during this period. So let's make some room here. Let's find the displacement. Well, to find the displacement, we just need to integrate that. In other words, find the antiderivative and evaluate it from 1 to 4. Plugging in 4, then subtract plugging in 1, we get a displacement of negative 4.5. So it ends up 4.5 meters to the left of where it started. The total distance is a little trickier. From the velocity has zeros at 3 and negative 2. Those are points where it could change direction. So since it could change direction at 3, negative 2 is not in its interval, so we're not going to worry about it. So since it could change direction at 3, it could be a positive or negative velocity between there and there. So we could have forward or backwards movement, the same thing between 3 and 4. So instead of integrating from 1 to 4 and seeing the total displacement, we're going to integrate from 1 to 3 and then again from 3 to 4, take the absolute value and make sure we get the total distance traveled there. So integrating from 1 to 3, we get this big, long arithmetic stuff to do, plus from 3 to 4. Notice it's going left from 1 to 3, and then it turns around and goes right from 3 to 4. It just doesn't come back far enough to get back to its starting position. It goes up approximately 10.17 meters total. So you might want to pause here and study this slide for a little bit, otherwise we're moving on. That's our target for today. I'll see you in class.